Hello and welcome back to Math with Miss Murthy. Guys, like I told some of my students today, this is my third attempt at doing a recording. But the last two times I didn't record for some reason, and this is going to be a quick video. I have about 12 minutes, so we'll stop right at about the 12-minute mark. As usual, I want you to go ahead and pause and do the warm-up on your own, and I'll share the solution. And pause again for the mathematical content to read the mathematical content requirement standards that we'll be covering in this lesson, and then the mathematical practices that we'll be using in this lesson. So in this lesson, this is again in your book, lesson 6.6, Inequalities, starts on page 377. We are going to write, solve, and graph inequalities. Now, an inequality is a sentence that compares quantities that may or may not be equal. This table is going to show us 4 inequality symbols, and which are greater than, less than, greater than or equal to, and less than or equal to. Now, a solution of an inequality is a value of the variable that's going to make this inequality a true statement. For example, 1 plus x greater than equal to 6. Right? If I choose a value of x equals 2, I would get 2 plus 1, 3, which does not make this inequality true. Whereas if I were to choose 5, 5 plus 1 is 6, which is equal to 6. Right? So anything bigger than 5 is going to be a solution of this inequality. I want you to take a moment and compare and contrast an equation and an inequality. Now, both equations and inequalities can contain numbers, operations, and variables. The solution of an equation, however, is exactly one value, whereas an inequality is a range of values. Okay, this is one value, this is a range of values, a set of values. Now let's look at the table below, which to see what words we could use to represent these inequalities. Less than, fewer than. Here we have greater than or more than. Here we have is less than or equal to, or is at most. That means the biggest value that it could take, which means anything smaller than. And over here is greater than or equal to, or is at least, which means at the very minimum it is this value, or it will be more than that. Okay. Now, as usual, we use our same steps. We describe the math, identify the keywords, we define a variable, very important. Define a variable to represent the unknown quantity, and translate your words into an algebraic inequality. To write an inequality, we're going to look for keywords like at least, at most, no more than, no less than or greater than. So let's look at this question. A person must be at least 18 years old to vote. Write an inequality to represent the possible ages of a voter. Right? Now here, we're told that age of a voter is greater than or equal to 18 years. So if we have A representing the age of the voter, my inequality is going to be A is greater than or equal to 18. Now, how do you know that the keywords at least is indicating a greater than or equal to symbol? Now, at least means that the quantity can be the same number or greater. So that's why we use a greater than or equal to symbol. Let's look at example 1. In some states, you must be at least 16 years old to have a driver's license. Write an inequality to represent the age at which you can have a driver's license. So now here, what are the key words that will help you determine which inequality symbol to use? Let's look at it. The keyword here is at least, right? So again, let A be the age to have a license. Our inequality is going to be A is greater than or equal to 16. Now, why is our inequality A greater than or equal to 16 and not A greater than 16? Because the inequality A greater than 16 means that I must be older than 16. You can't be exactly 16, but you can be 16 or older to have a driver's license. I want you to pause and do this check problem on your own, and I'll share the solution. There you go, W less than 50, as this was on page 379. Now, I want you to pause and reflect, and we'll talk about this in class. Refer to the example and check why do both of these situations represent inequalities and not equations, and explain your reasoning. Now, we're also going to look at graphing inequalities. Because an inequality like x greater than 5 or y less than equal to 100 has infinitely many solutions, it's not possible to list all of them. So we're going to graph them on our number line to help us visualize all the values, right? So the steps that we use to graph, when we are graphing an inequality, we're going to place a dot at the value shown on the inequality. Now an open dot, which is like a circle, means the number is not included. A closed dot, which is this filled in circle, means the number is included. So you need to be very careful to make this distinction on whether you're using an open dot or a closed dot. And then you're going to draw an arrow in the correct direction to which shows us all the solutions. So let's take a look at this. Graphing the inequality x greater than 3. We know that we're going to place a dot at 3. Now it's an open dot because 3 is not included here. And then we know that on the number line, values greater than on the number line are represented by the values to the right. So we draw our arrow to the right. Now, why do you think an open dot indicates the number is not a solution? Well, that's because the dot not filling in the dot means the number is not, the number itself is not graphed, and therefore it is not included. Let's look at the inequality x less than minus 1. Again, we're going to place an open dot at minus 1. That indicates minus 1 is not a solution. And because it's less than, we draw an arrow to the left. Now let's take a look at x less than equal to 2. We're going to place a dot at 2. This time, however, it's going to be a closed dot because it includes this. There is an equal to over here. And then we draw an arrow to the left to show any number less than 2 is also a solution. Moving on, why do you think a closed dot indicates the number is a solution? Because filling in the dot means that number is also included. Guys, this is we're now on page 381 of your book. Let's graph the inequality x greater than equal to minus 7. So again, we're going to place our dot at minus 7. And because we have the equal to sign over here, it is going to be a closed dot. And because it's a greater than, it's going to be numbers to the right. Now let's look at graphing the inequality x less than minus 5.75. Does not matter whether it's a negative number or a positive number. We're going to first look at what does a symbol less than tell you about how the graph is going to look. Well, first off, is it going to be an open dot or a closed dot? You gotcha. It's an open dot. And then less than means numbers to the left. So our graph is going to look something like this, superimposed on our number line. And we're going to put our open dot at minus 5.75. Now, how can we check that our graph above is correct? Well, you can use any of the values that are highlighted, substitute them in your inequality, and check if it's correct. I want you to do this check, pause and do this check problem on your own. X greater than 1 and 2/5. Let's look at example 2. Oh, this is the solution for example 2. Example 3, graphing inequalities, x greater than equal to 2/5. So again, what does the symbol greater than equal to tell us? Well, first off, the equal to tells us it's going to be a closed dot. And then greater than tells us it's going to be numbers to the right. So our arrow is to the right. So our closed dot is placed on 2/5 and all numbers to the right are valid solutions. Now, how can we check that our graph is correct? Well, like before, we can substitute any value bigger than 2/5 in our equation and check for correctness. I want you to do this check problem on your own. Graph the inequality x less than equal to minus 0.75. There you go, that's your solution. Now, we're also going to look at, we looked at infinite solutions. Now we're going to look at if we have a finite set for which we want to check if they're solutions, right? So when you replace a variable with a value, which results in a true sentence, we're going to solve the inequality. Now, the value for the variable is a solution. So some inequalities can have infinitely many solutions. For example, any rational number greater than 4 will make the inequality x greater than 4 true. So we're going to use substitution to determine if the whole numbers 5, 6, 7, and 8, and 9 are solutions for the inequality 2 plus x greater than 9. So we make our table just so we are clear, right? Value of x, our equation, whether the inequality is true. So you substitute for the value of 5, 2 plus x is 2 plus 5. That gives us 7 greater than 9. Nope, it's not true. The check for 6 is not true. Check for 7 gives us 9, which is not greater than 9, so it's not true. But for 8, 2 plus 8 is 10, which is greater than 9, so it is true. And same for 9. So we know that the whole numbers 8 and 9 are solutions of the inequality. Are there other solutions? Yes, there are. Anything greater than 8 is a solution. Can you list all of them? Nope, it's not possible to list all of them because there are infinitely many solutions. Okay. Now, similarly, we're going to do our example 4. Which of the following are solutions of the inequality a plus 4 less than equal to 11, 6, 7, and 8? Complete the table. We have the value of a, 6, 7, 8. A plus 4 is less than equal to 11. We have 6 plus 4 is 10, which is less than 11. It's true. 7 plus 4 is equal to 11, so it's yes. And when we substitute 8, 8 plus 4 is 12, which is not less than equal to 11, so this is false. So from the given values, our solutions are 6 and 7. So on this graph, you can see that 6, 7, and so forth are solutions. Now, using this graph, you can directly see whether 6, 7, and 8 are solutions of the inequality. You can see that 8 is not a solution. I want you to do this check problem on your own, and we'll stop right here.